So, good day, sir. Uh, Today we're going to discuss about bandwidth utilization. So, first is what is bandwidth? So, bandwidth it is the amount of data that can be transmitted over a network connection in a given time. So, bandwidth utilization. So, it's the wise use of available bandwidth to achieve specific goals. So, uh, bandwidth utilization it is about using your internet capacity in the best way possible. So making sure data flows smoothly without wasting or overloading the network. So instead of wasting a bandwidth on necessary things, it's about making sure it's used effectively to reach a goal like smooth video calls or faster downloads or stable connections when many people are online. So efficiency can be achieved by multiplexing. Privacy and anti-jamming can be achieved by spreading. So efficiency, multiplexing. So efficiency can be achieved by multiplexing because multiplexing lets many signals share the same channel or medium at the same time instead of giving each signal its own separate line, which is waste. So multiplexing combines them into one, then separates them again in at the end. So privacy and anti-jamming can be achieved by spreading. So privacy and anti-jamming it can be achieved by spreading because of the data is sent across many frequencies instead of just one. So this makes the signals harder to I this makes the signal harder for outsider to detect or understand, and also harder for someone to block completely.
Good afternoon, sir. So, multiplexing is a technique for combining multiple signals or data streams into a single signal to be transmitted over a shared communication medium such as wire, fiber optic cables, or a radio wave. Next is technique to share a single link among multiple signals. Multiplexing is the core concept. It is the method by which multiple signals can transmit simultaneously over a single communication channel. And next is definition: when link bandwidth to device needs to share link. So this explains why multiplexing is useful when the capacity of a communication link is greater than what a single device requires. Multiplexing allows you to share that unused capacity with other devices. So next is types of multiplexing. So we have frequency division multiplexing or FDM, and wavelength division multiplexing, the WDM, and time division multiplexing, TDM. Next, analog technique, channels separated by frequency. So analog techniques, channels separated by frequency bands. FDM is used with analog signals and divides the available bandwidth into different frequency ranges, each assigned to a separate channel. Imagine different radio stations broadcasting on different frequency. So for example, telephone systems, radio broadcasting. So these are classic example where FDM is used to allow multiple phone calls or audio broadcasts to occur simultaneously. So next is key figure, dividing link into channels. So this visual representation is crucial for understanding FDM, showing how the total bandwidth is split up. So highlight solve example. So voice channels into 12 kHz link. So working through a specific example like combining voice channels into a 12 kHz link will make the concept much clearer for your audience. Show how each channel gets a portion of the bandwidth. So next is the wavelength division multiplexing. So like FDM but for optical signals. So WDM or wavelength division multiplexing is conceptually similar to FDM, but it operates on optical signals which light instead of electric signals. So uses prisms to combine or split light signals. So prisms or other optical components are used to combine multiple light signals of different wavelengths onto a single fiber optic cable and then separate them at the receiving end. Next is, for example, fiber optic system. So WDM is essential for modern high bandwidth fiber optic communication, enabling massive data transfer. Next is the TDM, which is time division multiplexing. So digital technique, channels separated by time slots. TDM is used with digital signals. It divides the communication channel into time slots, allocating each slot to a different channel. So synchronous TDM, fixed slots even if idle. So in synchronous TDM, each channel gets a predetermined time slot regardless of whether it has data to send. This can lead to wasted bandwidth if some channels are often idle. Next is statistical TDM, slots assigned dynamically. So statistical TDM is more efficient because it allocates time slots only when a channel has data to transmit. This avoids wasting bandwidth on idle channels. So example, 4 channels at 1 kbps combined, output 4 kbps. So this illustrates the basic principle of TDM, combining the data streams from multiple lower bandwidth channels into a single higher bandwidth channel. So next is key figures, interleaving, framing, slot comparison. So this visual helps how data from different channel is interleaved or mixed together. So how frames are structured and how slots are allocated. So next is real applications. So real applications, telephone, networks, satellite, or satellite communication. So T1 and E1 lines are older example of TDM used in telephone systems. Satellite communication also utilizes TDM to share bandwidth among multiple users.
So next is spread spectrum. So in spread spectrum, we combine signals from different sources to fit into a larger bandwidth. So but our goals are to prevent eavesdropping and jamming. So to achieve these goals, spread spectrum techniques add redundancy. So what is spread spectrum? So it is a method of sending a signal by spreading it across a wide range of frequencies instead of keeping it on just one frequency. So, spread signals over a wider bandwidth and adds frequency. So, making the message harder to intercept or block the extra data, hides and protects the real information, ensuring privacy and resistance to jamming. So, first example is figure 6.27 spread spectrum. So a signal with bandwidth B is expanded into much wider bandwidth BSS using a spreading code. So the purpose of this is to make sure to make transmission more secure and resistant to interference. So next is figure 6.28 28, frequency hopping spread spectrum, so or FHSS. So the original signal is modulated and transmitted over different frequency. So pseudo-random code generator selects frequencies from a table through a frequency synthesizer. So the original signal is kay muagi siya sa modulator with the frequency synthesizer. So di diyan na may tabo ang pseudo-random code generator, then mag-select siya og frequency from a frequency synthesizer, then signals hops across frequencies to avoid jamming and eavesdropping. So next is figure 6.29. So frequency selection in FHSS. So a key bit pattern determines which frequency to use from a frequency table. So example, the 101 maps to 700 kilohertz. So each hop is chosen using these patterns. Then it shows muagi siya sa frequency table. Then diyan na makita ang frequency, first hop frequency. So next is the figure 6.30, the FHSS cycles. So it shows how frequency change or hop over in time in cycles. Thus the cycle 1 and cycle 2 follow different pseudo-random frequency sequences. So na siya lain-lain nga pseudo-random nga mga frequency sequences. So next is figure 6.31, the bandwidth sharing. So the A, frequency division multiplexing, each user gets a fixed frequency band. So the letter B, users share frequency over by hopping and reducing interference. So next is figure 6.32, the DSSS or direct sequence spread spectrum. So original signal is multiplied or modulated with a fast spreading codes or chips. So this produce a spread signal over a wider bandwidth. So that's all, sir. Thank you.
So summary and closing. So multiplexing equals efficiency. Reinforce that multiplexing is all about making efficient use of bandwidth. And next, spread spectrum. So privacy plus anti-jamming. Reiterate that spread spectrum provides security and robustness. So both are essential for modern communication systems. Emphasizes that both multiplexing and spread spectrum are fundamental technologies that underpin much of modern communication. So end with a practical link. That's why your phone, Wi-Fi, and fiber internet can all share lines securely and efficiently. So this connects the abstract concept to everyday experience, making the information more relatable and memorable for your audience. It highlights the real-world impact of this technology. That's all, sir.